Good morning, children. So, we have seen how the plane mirror is used to obtain the different figures, okay, in the previous session. Now, we will be discussing the lab activity, that is reflection of light by plane mirrors. So, here we are looking at reflection of light by plane mirrors. Children, let us do this in order to verify the laws of reflection. So this is the activity what we are going to do in order to find the reflection of light. Using the reflection of light, we are verifying the laws of reflection. So in order to do this, we need some of the materials. The materials are, one, we assume this as our mirror strip, okay, and mirror strip, drawing board, white papers, pins, clamps, scale and pencil. So all these things you require. We assume this as your mirror so that you can see this, understand this thing well. So let us take a drawing board and fix a white paper on the drawing board and draw a line, okay, either like this or like this, horizontally or vertically on this paper. Now you take a ray, okay, let us say this is your ray, line drawn over here. Take a line, a straight line using your scale, meeting this middle line. So consider a middle line is drawn on the drawing board, and then for this line from a point you are drawing a ray, okay, and two points over here on this ray and P and Q, and you insert two ball pins over here, over here and here, 2 points, 2 pins you are placing, and now you are placing your mirror at this position. So this is your mirror, this line, along this line, let us say this is your mirror. You just have to, okay, this is how you are going to place it. So this is your mirror now. So from down, when you are viewing it, you can see this P and Q points over there. So see from the other point and such that, okay, you can draw a perpendicular line before placing the mirror over here, and this is your normal, and view from the other side of the normal so that these two pins P and Q are visible to you, can be seen on a straight line, and fix 2 more pins on that straight line. Now join these 2 pins, join those 2 pins in order to obtain this, okay. So this picture will be shown to you over here, like, okay, these two, P I Q I, image of P and image of Q. Why I am keeping in order to make you understand about image of Q and image of P are seen here. So let it be a straight line is drawn from here, and after removing here you can put the dotted lines. So now you are getting it, and after drawing this, okay, you have to after obtaining this, you have to calculate different values. That means here you have done, for let us say this is 30 degrees. Now you have to tabulate the values that you have taken. So here serial number, angle of incidence, for which what is the angle of reflection you got, serial number, angle of incidence, angle of reflection is I equal to R or not. All these values you have to observe, yes or no. Just is this yes or no? Here you need to just put a tick mark if it is yes. All the situations, in all the situations, whatever the angle of incidence you are taking, the angle of reflection will be equal, you will be getting. So when we are getting all these equal, so angle of incidence is equal to angle of reflection, and we observe that all this incident ray, the reflected ray and the normal lying on the same plane of paper. So first law is incident ray, reflected ray and the normal lie on the same plane, that is the plane of paper. And second law is angle of incidence is equal to angle of reflection. So this angle is equal to this angle you will get. So for such 4 or 5 values you will tabulate to verify the values. You will find that it is equal. Definitely when you do it you will be getting. Okay. Then coming to plane of reflection. So coming to the plane of reflection. Plane of reflection. Plane of reflection means what? Generally, when we are putting the P and Q over here, let us say this is P and this is Q, then you will be getting your, okay, let us say R and S are the 2 other pins that you have placed over here. So when we are placing the P and Q over here, see that their heads are at the same height from the board. When these heads are at the same height from the board, so that becomes an incident ray, and the heads of R and S also, when they are same height, that becomes the reflected ray. And you can see this normal over there, okay, in the at the same height. So that becomes the plane of reflection. What happens if these pins are not in the same height? So if P and Q are not in the same height, then what happens? The plane of reflection will be just like here. If we have this much height and here we have little height, the plane will be like this. The plane will be a slopy plane over here, and that becomes the plane of reflection. So is the concept clear, children? Once the pins are placed at the same height, all the 4 pins are having the heads of the pins are at same height, then that plane will become the plane of reflection, and for that the normal will be lying in the same point, okay, same plane. So that plane, the height at which we are placing, that becomes the plane of reflection. If the pins are not in the same height, then the plane which drawn over the heads of the pins will become the plane of reflection. Coming to how does this mirror forms the image of a pin or any other object. Let us take the example. How does the so our concept, second concept is plane of reflection. Plane of reflection completed, and coming to the third concept, okay, image formed by a plane mirror, So this image formed by a plane mirror, one is a point object will form a point image. Second one, object of a certain height, object of certain height or size, certain height. So let us look for the first one. So this, let us suppose this is your mirror and this is your point object. So this point object, when light falls on the point object, so many rays will be coming from the point object, and let us consider any 2 points of this point object, and 2 rays you are considering. For at this point you draw the, at these 2 points you draw the normals to this point. Now these 2 rays will have the reflected rays. These 2 rays will have the reflected rays, and these 2 reflected rays, let the 2 reflected rays be drawn like this. That you can draw by measuring the angle of incidence and angle of reflection. You are making a point over here and you are joining from this point to that point. So you will be drawing like this, and now you extend these 2 lines to a point where these 2 lines are seems to be coming from. So if O is the object and these 2 point, okay, these 2 lines are appears to be coming from this point over here, and therefore this becomes your image. And if you observe this distance, okay, the object distance from the object to the mirror, this is your mirror. So this is mirror. The distance from object to mirror is called as object distance. Object distance, and distance from mirror to the image is called as image distance. Image distance. So if you observe this, these 2 are equal for a plane mirror, and you will be observing that the image cannot be formed on the screen. That is a virtual image. Okay. Coming to the second case, object of a certain height. Let us take an object, let it be your mirror. Then from the 2 top and bottom of the object, we will be considering 2 rays. 2 rays we will be considering, and this ray, as it is traveling here, take the normal at these 2 points. Okay. Now this becomes your reflected ray, and this becomes your reflected ray for these 2 rays. These are the incident rays, children, and these 2 points, it is meeting the mirror. So this is your mirror, this is your mirror, M dash, okay, and this is your O dash is the object. Now from this point, when you are taking a ray, so these 2 are angle of incidence and angle of refraction. So this ray is the normal drawn at this point. After drawing the normal, you can go for the reflected ray, making the same angle. How much angle it is, this normal and this line is making, with the same angle you can draw. And now this ray will be extended in the backward like this, and this ray will be extended in the backward like this, and this becomes your eye. And similarly you can draw 2 rays, okay, you can draw 2 rays over here and 2 more normals for these 2 rays, and this is your ray. So you can see the I dash. So now I dash. So if you observe this, the size of the image is equal to size of the object. The distance of object distance is equal to image distance, and you will observe that characteristics. Okay. So coming to the next one is fourth one, characteristics of image formed by plane mirror. What are the characteristics? So if you are taking an object of height, same height image is formed. Okay, first one, size of the image is equal to size of object is equal to size of image. Second characteristic, second one is object distance is equal to image distance. And third, the most important thing is, okay, it is laterally inverted, left as right, and vice versa, right as left. Then fourth one, the image formed cannot be obtained on the screen. That means whatever the image is forming over here, this image cannot be obtained on the screen, called as a virtual image. Virtual image is formed. So if you look at the characteristics, size of the object is equal to size of the image, object distance is equal to image distance, and it is lateral. The image formed will be a laterally inverted image, and that is left side appears to be as right side and the right side appears to be as left side, and it is a virtual image. It is not a real image. It cannot be caught on the screen, and it is virtual image. We assume, okay, we can see it, but we cannot make that image to fall onto the screen, children. So please try to understand. So we have seen reflection of light by plane mirrors and plane of reflection, and image formed by a plane mirror is categorized into object, okay, object of point size and object of certain height. So object of point size, we will see object distance equal to image distance, and they will be on the same line. So here, coming to the object of certain height, the same height image is formed. Based on these two, we have written the characteristics of image formed by a plane mirror. That is, size of the object is equal to size of the image, object distance is equal to image distance, lateral inversion as well as virtual image is formed by the plane mirror. Thank you.
Welcome.